To keep going on in redshift, you need more surveys and going to fainter fluxes to get access to more distant objects. And by doing so, doing so is not easy. These objects are very faint, and you need some long integration time to assemble a lot of data.
And you can see that you can marginally detect it with WMAP. We know, in fact, that WMAP is finding at this point 0.96 with a marginally significant deviation from scale invariance, when you could see that with Planck, this will be pinned down typically to the second digit without any problem.
So another motivation also to try to fit the dynamics of galaxies with more informalism is to try to solve the problems that the CDM is encountering at galaxy scales. In fact, you know that lambda CDM, the standard theory, is very good at a large scale structure and also to explain the CMB and so on. But when you simulate cosmologically the CDM, you find that the CDM is clustering too much in galaxies.
I will discuss review some of the classic tests on solar system scales and inquire whether and how they can be extended to cosmic distance scales. I will then speak in some detail about potential and even early realized tests of cosmological relativity, and then conclude.
First speaker is Rocky Cole, dark energy and back reactions.
I will talk about the possibility that the observations that are usually interpreted to be evidence for acceleration of the universe and dark energy is a result of back reactions of inhomogeneities in the universe. The remarkable and perhaps troubling aspect of this diagram is the fact that 95% of the universe is dark. We have no idea of its nature, dark matter and dark energy.
So singularities are predictions of general relativity, in fact in a regime where it cannot be trusted. So from this perspective, if you want to go beyond general relativity, then singularities are the natural gateways to physics beyond Einstein. Now it turns out, as we'll see, that the situation is very different in loop quantum cosmology. We'll see that physics does not stop at singularities, and quantum geometry, which is at the heart of loop quantum cosmology and loop quantum gravity, quantum geometry extends the life of space-time.
In fact, it appears that space-time should really be thought about as totally emergent. In fact, we have examples. In that beautiful example of ADS-CFT, in which there is incredible mathematical power can be brought to bear, one dimension of space, and all the dynamics of five-dimensional space-time emerges dynamically. You have a theory of gravity which is formulated in terms of gauge theories, in which the metric is fixed. There is no dynamical gravity. Gravity can be an emergent phenomena from ordinary non-gravitational physics if you grow space-time as well.
In short, in this meeting we have been discussing challenges. That tends to obscure, that's only natural. This is the way science is done. But it does tend to obscure the fact that we have this challenge because it rests on a very firm foundation of observational evidence, to say nothing of centuries of fundamental, well-tested physics.